All right, week 5, lesson 5 today is the science revolution. So we're not really talking about exploration today. We're going to focus on a completely different event. Everything else that we've been talking about has been relating to trade and wealth and government power, and we're talking a little bit differently today. We're looking at the impact of the science revolution. Some people will call it the Copernican Revolution. So what are our goals today? Our goals are to look at when did this revolution happen? Where did it happen? Why did it happen? Right? And then what is tradition versus reason? And tradition versus reason is really a summary of this revolution. And so tradition is something that you do. I think typically we say if you've done something twice, it's a tradition. But it may be that on the first day of school, there's something that you traditionally do. It could be something you wear new clothes, or you get a new book or new notebooks, or you have a certain dinner to celebrate the first day of school or the last day of school. Or maybe your family has a tradition for your birthday and how you celebrate birthdays. Versus reason, versus something that's a logical thing to do. And so a logical thing to do is on your birthday, you wake up and you eat breakfast. That's a logical thing to do because you have to eat. What might be a tradition is, do you have birthday pancakes? Are you allowed to eat birthday cake for breakfast? That's tradition. Reason is saying, I need to wake up. It's my birthday. I need to get up. I need to use the restroom. I need to wash my face and brush my teeth. That's reason. And so that's what we're going to look at with the science revolution. What changes occurred? So when we think of revolution, I want you to think of the word change. You've probably heard of the American Revolution, the French Revolution, the Haitian Revolution, the Russian Revolution. Those are revolutions involving governments. But you've probably also heard of the Industrial Revolution, or maybe the Digital Revolution, right? And so those are revolutions of change. And that's what this revolution is. It's a revolution of change. And we're looking at the important people that we see as leaders of this change. So just to review, we've spoken about colonization in the Americas, and this is important because there's wealth involved with all of this, right? You have Spain becoming wealthy, you have England becoming wealthy, you have France becoming wealthy. Well, not everyone was moving to the Americas. There were people staying at home and people becoming wealthy because of their investments, because of property that they were buying, because of goods that they were buying and selling. And so because of this colonization in the Americas, we see people in Europe becoming wealthier. And you have what's called rise of the middle class. Those people that do business, what we would say are white collar workers, people who are professional. More people you have lawyers, you have doctors are becoming more of a professional doctors, not just midwives and people who do something on the side, or herbal healers, but people who are seen as professionals. Right? We've talked about Asian trade, right? Going into Africa, India, and the Spice Islands, China and Japan. And so, think about, what did China and Japan wanted? They wanted that science knowledge. They wanted to know how to figure out things about the world. And this, I think, is just something innate about people. When I think of little kids, and when you go outside with a young child, they're going to ask you questions, right? Why is this leaf different than this leaf? Why does this tree look that way? And why are dogs this size? Or why are some dogs have long hair and some dogs have short curly hair? And so we just naturally ask questions. And so people naturally ask questions. And what does science do? Science helps to answer those questions. And I really think that as Europeans spread out and they start to see there's a whole big world they didn't know about, they're asking more questions. If you think about the Middle Ages, people pretty much, most of the people, the peasants, got up, they worked to survive, they worked to make food, they played music for entertainment, they had some dances, they went to church, they slept, they rose, they hoped they didn't get any diseases, they hoped that they lived to a decent age. And that was it. That was their life. They really didn't know much about the outside world. They probably didn't have time to question the outside world because they were busy surviving. But now, because of this wealth that Europeans are gaining, because of trade and new knowledge about the world, that tends to lead to more questions. Right? And again, change, transformation, different. All right? So we can describe the science revolution as starting in the 1600s. Starts a little bit before then. But they start to look to science. They start to look to finding answers to their questions about the world, not just accepting what they've traditionally believed. And so we really see science and physics and science laws that come about. It's the first time we have science laws, a science process that comes about, right? And what we really see that changes everything is the idea that the sun is the center of the universe. That shatters everything that we knew about the world before then. Now, during this time, you're going to find that the Catholic Church does not support this idea. They think that this is nonsense. And so I'm going to tell you why they think that. All right, so again, our big question is, where did people get their understanding of the world? Before the idea of the sun being the center of the universe, what did people think? All right, and again, science revolution, tradition versus reason. All right, we're going to start with the geocentric theory. And geocentric theory is what people used to believe in, right? That the earth was the center of the universe. So the root word geo means earth. Centric means centered, right? And we would say that the geocentric we do not believe in today. Right? But Aristotle, Greek philosopher, Ptolemy, a Greek and Arabian scientist, he believed, and they taught, and Plato taught, that the universe was geocentric, that the earth was the center of the universe. So for thousands of years, this is what people understood to be true. All right. So we look at the science revolution, we start with the ancient thinkers. Ptolemy. So the man's name is spelled Ptolemy, but it's a Greek name. So with the Greek, we drop the P and it's Ptolemy. All right. So Ptolemy is one of the people, he lived in the year 100. And Aristotle, of course, lived in the time of the Greeks before him. And these are what ancient philosophers, what we would say scientists, mathematicians, said to be true. All right. And so they state that the earth is the center of the universe. Now, sometimes you'll see this referred to as a Ptolemaic universe because Ptolemy is the one who wrote about it. All right. And we would say today it's a geocentric, earth-centered universe. So here in this image, you see the earth in the center. And so this is what people believed, and we're going to talk up until the time of the 1500s. So for over 2,000 years, people have believed that the earth was the center of the universe. And we still say some things that follow that tradition. All right. Not only did Ptolemy and Aristotle and Plato teach this, but the Catholic Church also taught this. Okay? And realize that most of the European universities are run by the Catholic Church. If you are going to be a priest in the Catholic Church, you are going to be well educated. They were usually the more educated people in an area. Right? And so the Catholic Church said, we support this idea of an earth-centered universe because if you read passages from the Christian Bible, there's passages that support that. So I have a couple of passages here from Genesis. God created the earth on the first day. Boom. Right? And then what does he do? Then is the sun, the moon, and the stars to give light upon the earth. So therefore the sun and everything else is around the earth. The earth is here, everything else is around it. Right? And then in Psalms we also see, yea, the world is established. Boom. It shall never be moved. There's also a few other phrases that you can find in the Christian Bible, and the words tell you that the earth is fixed in the sky. All right, so we have the ancient beliefs of geocentric, and these are from people who would not be Christians. And then we have the Catholic Church that says, yes, what these other people said agrees with what we said, and therefore it must be true. And then we get an opposing view. We get the idea that the sun is the center of the universe, right? And you've probably known that since before you can remember. Probably can't remember a time when you didn't think of the sun as being the center of the universe, because it's common knowledge. So helio refers to the sun and centric, and the heliocentric theory, or the solar system, right, sun-centered system, is what we believe in today. And you cannot prove it to be wrong. You can set up experiments, but we cannot prove that the sun is not the center, and therefore the sun must be the center. It's that reverse type of thinking. But if we go back in time and we think about the Earth being fixed and the sun going around it, we still use terms that refer to that. If you've ever said that you saw a sunrise or watched a sunset, think about what you're saying. You said, I've seen the sun rise, I've seen the sun set. That would mean that the Earth is still and the sun is going around you. So we still use those traditional phrases, even though we understand that the sun is not moving and it's the people on the Earth and the Earth is moving. So everyone's believing that the Earth is the center of the universe. Everyone's fine with that. Until we get a man by the name of Copernicus. And Copernicus lives in Poland. Right? And he is a member of the Catholic Church. He's been educated in the Catholic Church. Very smart man, does a whole lot of math, he does a whole lot of writing and science. So he's working for the church, but then he also has a side interest. And this was very common in this time period. You'd have people that worked with the church, but they were doing something else also. Sort of like a hobby of his. Very serious hobby. So in 1534, he publishes this book. And in the book, he says, I really, really think that the sun's the center of the universe. Or the sun is the center and the earth moves around it. He said it would just make sense. There's so many things like the phases of the moon and some of the phases of the planet, and it could just be better explained, and seasons, if the sun was in the center and the earth was moving around it. All right. So he writes this book, and he dies just shortly after he writes his book. So he never gets to teach about it. He doesn't really get to discuss his ideas with anybody. But because the printing press is out, his book gets translated into different languages. And there's a few other scientists who are going to read his book. So we have a man named Kepler, Johannes Kepler, and he lives in Germany. And he reads the book by Copernicus. And he's an awesome mathematician. If you are into music, he did a wonderful writing on music and harmony, the music that math that's in harmony, math that's in music. And so he writes about math and religion and astronomy. And again, these are people that just had brilliant, brilliant minds for the time. And he says, not only is the sun the center, I believe that Copernicus was right, but if we imagine that the planets move in an oval or elliptical pattern, that would explain things even more. That would just make more sense. While we don't see all the planets in the sky every night. It's not that they disappeared, they're just too far for us to see them. And he writes a book. So if you want to get talked about in history, write a book. Right, so he writes a book, and he says this guy Copernicus was right, read his book, I agree with him, and this is why. And then we get probably the most famous of them all is Galileo. So Galileo lives in Italy. And that's probably his biggest problem. So he lives in Italy. He actually teaches at the University of Pisa. He grew up in Pisa, Italy. He does a lot of his science experiments from the Tower of Pisa. Okay. And he reads the books by Copernicus. He reads the book by Kepler. He says, man, these guys knew what they were doing. That explains so much because Galileo has invented a telescope. The Dutch were master glass makers. And I'm talking about glass, I mean lenses, like eyeglasses. And so that's why we see the microscope being invented in Holland. And so we see Galileo takes what would be a spyglass used for sailors on ships, and he has the lenses created, and he makes a telescope. And it's really not that big. It's amazing. I mean, you could pick up the telescope, and he's able to see the moons of Jupiter. And he says that elliptical revolution would make perfect sense why I see some moons sometimes, and then other times I don't see the moons. And so he writes about it. And not only does he write about it, he teaches it. And this is what gets him into trouble. Okay? Is he starts teaching that the world is sun-centered. He teaches that the planets move around the sun. And at this time, the Catholic Church is really cracking down on people who are speaking out against them. This is the time of the Reformation in Germany, where people are creating new Christian churches like the Lutheran Church. You have Henry VIII in England, who's created the Church of England, breaking away from the Catholic Church. So the Catholic Church is starting to lose power in Europe, and they're trying to hold on to that power. So they come to Galileo and they say, dude, you got to stop it. You got to stop what you're teaching. Teach the math stuff, pendulums. You're talking about that? That's great. That's wonderful. You have to stop. Just stop saying that the sun is the center of the universe. It's nonsense. And he's like, well, why don't you come and I'll show you. We'll go to my telescope at night and I'll show you and explain it. And so members of the church go, and they are so against what he's teaching that they explain what they see by saying he had to have painted something onto the lenses. Must have been some type of magic that he's trying to use to fool them. So Galileo is tried for heresy, for teaching against the Catholic Church, which would carry a penalty of death. He is found guilty. And they want him to recant. They want him to say that he was wrong and the church is right. And he's like, can't do it. It's true, can't do it. And so he's placed under house arrest. Now, most likely the only reason he is not killed, executed, is because he was extremely famous. And people would buy tickets to come to shows. You'd have people with like paper mache Venuses and then the moons dancing around them. And there would be these great spectacles with fireworks. Different kings knew him. So he was people knew Galileo in the household. You didn't have to go to college to be taught by him to have heard of him. And he wrote quite a few books that were well read. So he's placed under house arrest. So this way he cannot teach. People are monitored who come to see him. He can't write any more books. His books are banned. And so that's Galileo. So Galileo, we would say, sort of really starts the science revolution because he's the one who teaches it. But the knowledge that we have on the science revolution really starts with Copernicus. And that's why some people will say it's a Copernican revolution. But Copernicus died long before this happened. Kepler is still around, but Kepler is, remember, in Germany. Galileo's misfortune is that he's publicly teaching this, and he's teaching it in Pisa, Italy, which is very close to Rome. And so it's very easy for the church to arrest him and put him on trial. All right, so let's look at some other people that are known for changing ideas and looking at the world in a different way. We have Francis Descartes, right, who lived in France. And he's famous for being said, cogito ergo sum, I think, therefore I am. And he's a very famous mathematician, and he truly believed that math could, pardon the pun, solve all your problems, right? And so he said, if we look at everything mathematically and in the simplest forms, we can figure out our answers. And he said there were 4 rules for reasoning through a problem. except nothing is true unless you see it for yourself and you 100% firmly believe it, and you can compare it to other things, you believe it to be true, don't accept it as true. So just because you read about it or were told about it, that's not reason enough. Divide everything into the simplest parts. Right? So if you're trying to figure out maybe what is the center of the system of your planets, maybe you figure out one thing first, and then you start to look at the other parts. Right? And then always recheck your reasoning. Go back through to the start and make sure there's no errors. Right? And then we have Francis Bacon from England. And there's actually a few famous people named Francis Bacon. So be careful if you look up Francis Bacon. This is the Francis Bacon who is a scientist and was born in 1561. He's also the Francis Bacon who dies freezing turkey. He was doing a science study on freezing meat, and he died in the winter from pneumonia, from being outside and doing his science experiments. Remember, 1561, you don't have freezers. So I don't know the details of the experiment, but that's probably what he's known for more than anything else. And his famous quote is, "Knowledge is power." And so he comes up with what he called the Baconian method, which we would today call the science method. And he says you describe your facts. What are you starting with? You use math to run through your problems, and so other people can see what you're doing. And if you can't explain something, you don't accept it as truth. You note it and observe it, but you don't say that it's true unless you can explain it. All right, and then we have Isaac Newton. So we start the science revolution with Copernicus, and historians typically would end it with Isaac Newton. So Isaac Newton in 1642, born in 1642, and I think it's interesting, Galileo dies at that point, and this is where Newton, so it's like Galileo is also part of the start of it, and then we have Newton picking up where Galileo leaves off. And so he comes up with science laws. And I don't want to say he comes up with, but he writes and describes. And so what he does is he says, if we can test and test and test and try to prove ourselves wrong, and we're not able to prove ourselves wrong, then it must be true. All right. And so he continues some of the experiments like the speed of falling objects that Galileo was working on. So Galileo would say, if you have a leaf falling from a tree and an apple falling from the tree, right, which object is going to fall faster? Right? Well, the apple will fall faster than the leaf, but it's because there's air under the leaf. If we reduce this leaf and crumpled it up and made it smaller, it would fall at the same speed as the apple. And Aristotle said no. So again, what we see in the science revolution is basically people proving Aristotle to be wrong. And Aristotle said that light things fall slower to the ground than heavier things, that the mass or weight determines how fast something falls. In theory, that's true. But if we put these objects into a vacuum where you had no air, they're going to fall at the same speed. And so that's one of the laws that Newton writes and has not been changed since his writing. He also determines or defines the laws of motion, right? So he's a tremendous physics worker. And of course, he's known for the apple falling, but he sees it instead differently. And so Newton, isolating himself because the plague has broken out in London, goes to his country manor. And you can imagine he's incredibly bored because there's no internet, there's no Netflix or YouTube. And so he's sitting around and he's looking outside his window and he notices that the apple drops from the tree. The leaves drop from the tree. But for some reason, he gets a flash of inspiration. He says, wait a minute, that apple separates from the tree, but why is it dropping? It's not. It's being pulled to the ground. Even if there's a breeze and the leaf gets pushed up, it's still going to come back down. Everything's always coming to the ground. And so that's where his writing on the law of gravity starts. That's where his inspiration. It's also his inspiration for calculus comes about there. So boredom is wonderful for creative people. And he also says the universe is very ordered. He said it's not random. Things are put together for a reason, and we see patterns in nature. And so that if you think of science, scientists look for patterns. Some of the earliest things we do as kids is we like to pattern our toys, right? You like to put different markers that are the same. So I could put like my pink markers together and my green markers together. And then I could say, well, wait, I have 2 slim markers and then 2 thick markers. So these are also the same, right? I could put them into these groups. And then I could say, well, this is my thinnest marker. And then this one's thicker. And then these would be equal. So I look for patterns and order. And that's what Newton said is true about nature and the universe. So that's a big idea that comes out of the science revolution. There's nothing random. The world is very ordered. And if you think about Greek gods, Greek myths, right? Why did they develop? They developed because people were looking for answers to questions, to things like natural disasters. Why do we have a flood? Why do we have drought? Why do we have fire? Why do we have lightning? And so if you don't have an answer, they said, I don't know, it's got to be the god of lightning. Zeus is mad, hence the lightning. Well, instead, during the science revolution, they're saying, wait a minute, maybe we can explain exactly why there's lightning. And these scientists believed in a higher power. None of them were saying that faith was wrong. They actually said what their science was doing was proving, above all else, that there was a faith, there was a higher power, because things were not random, and there was a connection in the universe. So thanks to my fellow history teachers, Tom Ritchie, appreciate his graph here, right? If we look at the scientific revolution, it happens during the 17th century. It lays the foundation of what we now call science. That wasn't really even a term before this time period. And they do science, to answer questions. They're not trying to change the world. They're not trying to bring down the Catholic Church or take people away from Christianity or say one is better than the other. They're just saying, this is what we see, this is what we understand. And in fact, the majority of the scientists were extremely religious. And so they were not seeing it as a separation of ideas. So one of the ways that I like to organize information is use mnemonics, right? Where we take letters of something that we're learning and we put a phrase with it. So you might want to try to do this for yourself or make up something for you that makes sense. So I have Ptolemy in the Catholic Church, and both were politically correct. Kings supported the Catholic Church. Therefore, Ptolemy supported the kings speaking, and Ptolemy supports the Catholic Church, and so they're all interconnected. You have Copernicus, who says that the world circles the sun. You have Kepler, who keeps the planets in elliptical motion. Galileo, who goes against church and gravity. Even though he also believed in gravity, he just did not describe it as well and do the experiments to prove it to be correct, like Newton does. Descartes decides math solves all problems. Bacon believes he has a science system. And Newton has new laws of motion and gravity. So this is a great way, if you're trying to organize your thinking, is take the first letter of what you're talking about, like N for Newton, and say, oh, he did the new laws. And that's a great way to remember this. So heliocentric is what we believe today, that we have a sun-centered solar system, right? Unfortunately for the scientists of the time, it went against what the Catholic Church supports. And then Ptolemy's idea of a geocentric universe. and Aristotle also. And then Galileo and Newton, Newton builds on the work of Galileo. In fact, a very famous quote of Newton's is that he stood on the shoulders of giants, and those giants being the scientists of the science revolution. Okay, both of them teach at university level. And then science laws that we get are laws of motion and the laws of gravity. So what were the impacts of the science revolution? Right? Science becomes more precise. It's not random. You follow a set system, you write down what you have, and you communicate it with others. So Latin was the language of science at the time, and Greek, coming from Aristotle's work and Plato's work. And so because of that, that's why so many science words have a Greek foundation. And they use that precision and they use that similarity because you have many people in Europe speaking different languages. So they all write in Latin, and that way they can all understand and communicate with each other. And it's okay to question the world. It's okay to question what you've been told. And this goes against the order that the Catholic Church wanted. And in honesty, for the Catholic Church to defend them, they see their job is to protect the souls of the people and to keep power. And they truly feel that, and this is what historians view, is that the church felt that if people believe this science idea of a sun-centered universe, then they would believe the church to be wrong. If they believe the church to be wrong about the solar system, what else might they believe the church to be wrong about? And therefore they might choose to leave the faith completely. And so that's where the fear comes in. That's where the loss of power, it ties in greatly with kings that are in power and have the support of the Catholic Church. All right, and then we have to look at the changes in technology. Huge revolution in technology. Telescopes become invented, microscopes using that Dutch Dutch glass lens technology. Prisms. Newton does a lot of work using glass prisms, right? Finding the colors of light. And of course, the printing press. Without the printing press, this knowledge, Kepler would not have read what Copernicus wrote, and Galileo would not have read what Copernicus and Kepler wrote, and no one would have read what Galileo wrote outside of Italy if it had not been for the printing press. All right, so next lesson will be enlightenment. And enlightenment is going to pick up where the science revolution ends, right? And so we're also going to do a comparison of the two because they're very different. And people tend to lump them together. The science revolution is definitely an idea of thinking and science and order and math. And honestly, it gets appreciated at that point. And part of the reason the science revolution comes about when it does is because of all the trade that we talked about. You have people that are wealthy enough to get paid to do science, or they're wealthy enough because their family has money, like Newton's family was fairly wealthy. Galileo gets his money from his teaching and also from writing his books. And so these people have money, and other wealthy people will patronize or support scientists. And so we see that going forward. You have Benjamin Franklin, probably one of the greatest early American scientists, who is very similar to these people. He's always reading and looking at new ideas and creating. We have Lavoisier, who is a chemist in France in the early 1700s. He does a tremendous amount of work with chemistry. We have Boyle. We have discoveries about Galen and stuff with discoveries of the human body. And so Englishman Harvey, discovers that the heart pumps blood. So there's so much knowledge that develops from this time period. As much as the world learned academically about there being continents, they're really gaining knowledge now about the world that they live in, not other worlds outside of them and other cultures, but just their own world in Europe. So this would have been an amazing time, a time of great change. People would have been arguing. This didn't go down lightly. You had people who were either definitely for science and people who were against science and these new ideas. And so we see just a tremendous amount of change. I mean, there were poems written about this. I'll send you a poem on John Donne writes Astronomy of the World, and he's just pulled to pieces about this. This is not something that comes easily, and people definitely are taking sides against this. And I think it's good to look at this in history because we can see it's not just now in the 2020s that we have differences of opinion. It's not just now in the 2020s that some people support science and some people don't. I mean, look what happened with COVID, where how many people were so strongly supporting one idea and some people were so strongly supporting another idea. And if you look back on those events where people were trying to figure out how do you handle this virus that we didn't know it, very similar to what's going on with science revolution. Who do you trust? Who do you believe? How do you know what's true and right? And so science became sort of our go-to, right, during the early parts of COVID. And then you had other people who said, no, we don't trust science, or which scientists do you trust? And then, of course, you have social media, which speeds up communication more so than the printing press did. And again, who do you trust then? And so times don't change, people don't change. It's the issues that we argue about. And sometimes it's only in hindsight that we can get a clear understanding of it. And these people weren't appreciated by everybody at their time. But now we can look back and say, hey, these guys nailed it. They knew what they were doing. So anyway, that is the science revolution.